no, we still don't have an answer. We only have an upper limit. So now, if for those of you that were here yesterday, you may remember that spin currents are very intimately connected to spin dynamics. And there's actually lots of interesting applications of spin dynamics, spin torque oscillators and what have you. But here's one that not many have seen, not even in the magnetism field. It's something that I discovered. It's a device about this size. And I discovered it in a pub in England. And it's on every counter. So it was in this pub, the Queen Victoria pub. And here it says spin to snork. So snork is a colloquial English term for kissing. So if you can't figure out how this device works, I'll explain to you later. But it's fairly straightforward. The instructions are here on the side. But the unusual application of spin dynamics that we use is spin pumping. So here the idea is, if we have a ferromagnet and a normal non-magnetic material next to each other, we can generate a spin current in the normal metal just by exciting magnetization dynamics in the ferromagnet, without using any electric current supplied to the device. How does that work? Well, so here's schematically our ferromagnet and our non-magnetic material. And so they have, schematic band structures like this, something you saw yesterday already. So now if we have an electron in the normal metal, it can diffuse around. And once in a while, it hits the interface here with the ferromagnet. And when it does so, it gets reflected or transmitted across this interface with probabilities that depends on the direction of the spin, right? Because depending whether the spin is up or down, there are more or less states in the ferromagnet that the electron can go into. Now, if we excite ferromagnetic resonance, meaning that the magnetization in the ferromagnet precesses, let's say, a simple circular precession, then these reflection and transmission at this interface is not only spin dependent, but also time dependent, because the quantization axis for the spins is essentially the magnetization of the ferromagnet, and it changes continuously in time. So in every moment in time, it's a different spin that gets transmitted or reflected better at the interface. Now this, in turn, ends up pumping spins into the normal metal, just like a water pump, really. And so what you end up with is that you generate a spin accumulation in the normal metal such that you have more of one spin direction versus the other. And it's a spin direction that's opposite to the magnetization of the ferromagnet. Now, the spin accumulation that you generate here at this interface can then diffuse away